I can ask A. So the function is given, and I can tell you that x1, x initial, so you will start from -1. V initial, let's say that is 3 meters per second. That's it. That's what I'm giving. So this is at 0 time. At 0 time. Initial time. So the question, find A, the change in velocity, between, or the velocity, the change in velocity between time equal 0 and 3 seconds, which is the same because you start at 0 or you start here. So find the change in velocity and find the velocity final at 3 seconds. B, find the position function as a function of time. And find what will be the position at 3 seconds. Same question. Now instead of giving the function of the position, I'm giving the function of the acceleration. So, how can we answer the question? We want to get the change in velocity. We have the acceleration. What did I say that is the physical meaning? If we have a graph A versus T, how can I get the change in velocity? Finding the integral, which is, what is the geometrical sense of the integral? The area under the curve. Can you see there the area painted? So I am asking for that, right? I am asking for delta V. You know that you need to get the integral. So the area under the curve. I go and I said delta V, by definition, is the integral of V dt. This formula is not given in the test. What is given in the test is this and this. So A is dV over dt. How do you know that delta V will be the integral of A dt? You apply the second fundamental theorem of calculus. So if I have A dV over dt, what do we do in order to find V? We find the integral in both sides. When you get the integral of dV from V initial to V final of dV equal the integral from 0 to t of A dt. This is the way that we solve this, right? In both sides, we have to solve the differential equation. We have to solve the integral. What is V final? This. What is the integral of the derivative? Yes. No.
Oh, B.
Yes, B. The integrand. Or the argument here. So, because this derivative or antiderivative cancel out with the derivative, we get V. From where to where? Because it's definite integral. On the other side, what we get? The integral of A from 0 or from T1 to T final of A, which is not constant, dt. We need to solve this integral. But what is V final minus V initial? Delta V. So delta V is the integral from 0 to t of A dt. If we want to get V final, what we have to do? What is delta V? V final minus V initial. So what can we do in order to find V? If you have V final minus V initial equals something, how do you solve for V?
Delta V plus V initial.
So V final will be this plus V initial, which is V initial plus this. Is that right? So this is the fundamental theorem of calculus, right? I didn't do anything else. So you know that delta V is the integral of A dt. Correct? So now, knowing this, we will do the same thing now with numerical value. So if I am looking for delta V, as I said, is this. But what is VO? So I am looking for this, which is V minus VO. What is VO? 3 meters per second. Did I give that before? Equal to what? The integral from 0 to t, 3 seconds, of the acceleration. What is the acceleration? Negative 2t dt. So, if I am looking for V final, will be V minus 3. If I am looking for delta V, this will be delta V. If I am looking for V final, will be, if I am looking for delta V, which is this, will be the integral. In this case, will be negative 2 t cubed, t squared over 2, right? From 0 to 3. This cancels out, and we get negative 9. Negative 9 meters per second is the change in velocity between 0 and 3. That's the change in velocity. So, but if I want to find V final, to that change in velocity, what I have to add? 3. So how much will be the velocity at 3 seconds? So will be 3 plus what I got before, which was negative 9. How much is V at 3? Negative 6 meters per second. That's it. This is my answer. But what I can reconstruct V final, because I have the initial condition, I have the initial value. If I don't give the initial value, you cannot find anything other than delta V. You understand what I mean? If I don't give the initial position, the only thing that you can get is delta V. But if I give the initial position, then you can get the initial velocity, you can get the final velocity. All right. Now, the next question was find x as a function of time. X as a function of time. What can I do? Now I have the velocity, right? If you go to this concept, what did I say here? If you have the velocity graph, or the velocity function, what is the area? Delta x, right? So in order to get the position, I need to do the same, but on this graph, on the v versus t. So what will be, according to this, v is dv dx over dt. I will do the same. dx equal v dt. In order to solve for delta x, I need to go from xo to x final, and here from 0 to t, or from whatever time I am given. So what is this? Delta x, which is the integral from 0 to t. In this case, I am asking from 0 to 3 of v. What is v? What was my v function? If you look at v function at any time, what will be v at any time? Will be negative t squared plus 3. This is your v at any time. So with this v, I can come here and I can put it here. Negative t squared plus 3 dt. Because I know what is x initial. How much is x initial? Negative 1, right? Negative 1 meter. So negative 1 minus minus 1 equal to the integral of this. How much is the integral of negative t squared? Negative t cubed over 3 plus, what is the integral of 3? 3t. So my x will be, I move this to the side, which is positive, negative 1. That's the constant, the c. Like if in the indefinite integral you get negative t cubed, which is how much? I'm looking from 0 to 3. Negative 27 over 3, negative 9. Plus 3 times 3 is 9, right? So 9 minus 9. So your final position, your x at 3 seconds, how much? Negative 1. This is by chance, by chance. This is not because, so your function will look like this, maybe, you know, like so at this point was negative 1, and at this point was again, so at 0 point, at 3 seconds will be negative 1. So at the beginning was negative 1, it will go like this, and then at 3 seconds it's also negative 1. It's by chance. The curve is a cubic function. You understand what I mean? Since it's a cubic function, it goes up and then down. And